Good morning, this is Irv Shapiro with the Dr. Vax channel. And today we're going to take my new Ender 3 that you see here in the background. This is an Ender 3 version 2, which is really a delightful printer. A little hard to assemble. You can look at the assembly and learn more about that in the video up above, but I'm really enjoying this printer. There are a couple of negatives, a couple of concerns that I'll point out that I found as I've used it more, but today we're going to kick it up to the next level by making it accessible remotely over Wi-Fi. And we're going to do that by installing Octoprint into a Raspberry Pi and connecting to this printer. Now we're going to do this using the most recent software available in terms of tools and the Raspberry Pi hardware. And we're going to do it in a way that you can follow for both a Mac and a PC. So stay tuned and let's learn something together. Now, to make this project successful, we need a number of things. We need some tools and software available over the internet, and we'll go through up front what websites we're going to use, and then we need some hardware. The first thing you'll need is a Raspberry Pi. This can be a Model 3 variant of the Raspberry Pi or a Model 4 variant. I'm using the newest Model 4, and one of the reasons is the price is almost the same, and you get a much faster processor in addition to additional input-output ports. But because you have a faster processor, it will be possible for Octoprint, and we'll give you some more background on Octoprint in a minute, for Octoprint to be used with more advanced plugins, and I'll explain what those are. So you need a Raspberry Pi. Now, the next thing you'll need is a power supply. I recommend you buy a power supply specifically made for a Raspberry Pi. The power supplies for the Raspberry Pi 3 have a micro USB connector. The power supplies for the Raspberry Pi 4 have a USB-C connector, so it's a more modern connector. One of the nicest parts of buying a Raspberry Pi from CanaKit is when you buy them as a kit, they give you the power supply of the Raspberry Pi, optionally a case. They also give you a little switch. So there is no power switch on a Raspberry Pi. So you put the switch on the end of the power supply, and then it gives you an on-off switch for your Raspberry Pi. I like that a lot. Now, in addition, you need a USB cable to connect to your printer. The style of USB cable will vary depending on the printer. Specifically, the printer end might be a micro USB connector, might be a printer style USB connector, so you have to check that ahead of time. But beware, inexpensive USB cables, such as this micro USB cable that I found in one of the drawers behind me, that probably came as a charging cable with some device, will not often work. They won't have all the right pins connected. They won't be wired properly. So if you use a cheap USB cable and you go to connect to your printer and it doesn't work, it might just be the cable. So this is a higher end branded cable specifically for data and power. Finally, optionally, you're going to want a camera. One of the nicest features of Octoprint that we'll look at is the ability to watch your prints. Now, I've used a range of Logitech cameras. I haven't found one that doesn't work. So you can get a low-end Logitech camera for about 30 bucks. That will be more than adequate. This is a higher-end Logitech camera. It's probably an $80 Logitech camera. I think this is a 930 or a 920. But pretty much any Logitech camera works. In fact, there's a list on the Octoprint website. We'll look at the Octoprint website in a moment of cameras that are supported. Now, let's look at the software. And we're going to do that by first looking at some websites together, then actually installing the software to show you the step-by-step. The first website we're going to go to actually has nothing to do with Octoprint, but just is a real advantage of buying a Creality printer. Let's go to the Creality website. And you'll see here the Creality website is quite attractive nowadays. Creality has really been stepping up their game. They have a wider range of printers. Their printers are more professionally produced, and even their website is more professional. So if we go to their website and we click on the right-hand side to support, and we go to download, and this is Creality.com. This is their China corporate site. And if we scroll down, we'll see pictures of various series of printers. On the bottom, you'll see various manuals. I'm going to click on Ender series, and remarkably, you'll see here the firmware updates for all of the Ender style printers. And the Ender 3 V2 printer, which is the one I have behind me, already has 3 files here. It has a copy of what ships on the original SD card. It has a file listed as latest firmware, and then it has a file listed as BL Touch firmware. Now the size of the file for the BL Touch firmware and for the latest firmware are identical. I did a quick binary diff. They also came out as identical. I might not have done that right. So it may be that the latest software has BL Touch capability if it senses a BL Touch. Because I did install the latest firmware, including I tried the BL Touch firmware, and there were no additional options on the menu. As an example, an additional option to adjust the Z offset, which is something you'd use with a BL Touch. Now, let me clarify a point about Ender 3 version 2s. They have a built-in bootloader. That's the software that loads firmware off an SD card in this case in order to upgrade the firmware. How does that work? You put one of the .bin files on the SD card. Now it's not clear whether you should have only one or you can have multiples. I've always put only one. But here's the trick. If the .bin file has the same name as the last one loaded, it will not reload it. So if you want to change, let's say you're building your own version of Marlin and you want to change the firmware, you should name each version differently. Now let's start looking at Octoprint. Octoprint is an open source project primarily directed and built by one woman. She's done a remarkable job on this project and has designed it with a plug-in architecture. That means there's the core Octoprint software, and then you can add in additional components. You'll see it's listed as providing full remote control and monitoring, 100% open source. Gina, the author of Octoprint, has a couple corporate sponsors that help support the project. I think if you're going to use Octoprint, you should become a Patreon of Gina's. The software is updated often and is just a remarkable addition to the 3D printing community. Now, if you go to the Download tab, you'll see a Octoprint build called Octopi. That's the version of Octoprint for a Raspberry Pi. There are versions for Windows and Linux and Mac, and you can run on other machines. I'm not sure why you do this. This is about, I don't know, $25, $35, $40 computer, depending on which model you buy. And it seems like a really good investment to have your 3D printer controlled by a standalone device. So you don't have to leave your computer on, so you don't have to worry about what else you're doing on your computer. Octopi is the Raspberry Pi build for this computer. So we're going to download Octopi, and the version here is 0.17.0. I've already done that, but that's the first step you're going to want to do is to download Octopi. Now, how do you get Octopi onto this computer? Well, this computer has an SD card, a micro SD card, one of these little tiny things, and you have to put the software in here, but you don't just copy it to here. You have to put an image file on here. That's a file organized in a way that a computer can load from it. Now, it used to be that you could use a variety of third-party software. One was called Etcher for this purpose, and that worked fine. There were different ways to do it, but the Raspberry Pi Foundation, the people who support making these boards, have produced their own software now called the Raspberry Pi Imager for doing that. That's what we're going to use. So if you go to the Raspberry Pi download page, it's raspberrypi.org/downloads, you'll see there's an imager for each of the operating systems. And that's what we're going to use to put the software on this board. So let's get started. I'm going to put this into my computer. I have an adapter here because my MacBook Pro does not have an SD card built right in. I've already downloaded this imager. So we're going to run this program. You can see it comes up here in the middle. We're going to choose an operating system. Now, the imager is designed to load software on the Raspberry Pi to make it more or less a general purpose computer. And they give you a number of choices. I'm going to choose Use Custom. But one of the things I want to point out here is that a lot of the newer 3D printers that use 32-bit boards require that their SD cards be formatted precisely in FAT32 format. That's a particular format for the SD card, and you have the ability to do that with this imager. So this imager is also a very good way to prepare an SD card for your 3D printer. So I'm going to say Use Custom, and in my software directory here, I have the 0.17 image that was a zip file. I double clicked on it to open it up. It opened to an image file. I'm going to select that file. So you can see here that there's the Octopi image we're about to burn. The imager is smart enough to only show you SD cards. It won't show you your hard drive. Now, I guess there are some cases, as an example, if you were running it on a machine where you used SD cards, USB drives of various types, those could show up, so you have to be careful. One way to be careful is you'll notice this is showing up as 31.9 gigabytes. That's the correct number. If I take that out and I say choose SD card, you'll see nothing shows up. So a good way to make sure you have the right card is always to first click on choose your SD card and see what shows up. Then add the SD card you're going to be working with. Click on choose SD card, and the new addition to the list is your SD card. So I'm going to select that and click on write. It's telling me that's going to start from scratch. That's fine. And now the imager does use protected features. It may actually use some Mac utilities underneath. I'm not actually sure, but it does require a password to work on a Mac. I'm not sure about a Windows machine. It might require a password there also. And now I'll get a message that it's writing. Okay, our image has finished. You'll see the screen here. We're going to take and remove the SD card from the reader. And now that I removed it, I'm going to put it back in. And then our local machine, in my case a Mac, will see it as a disk drive. So we're going to put it back in. Okay, we've placed the SD card back onto our computer, and you'll see it shows up as a file here, as a disk. I'm going to double click on it. And inside here, you'll see there are a whole bunch of files. We're really only interested in two. This file right here, Octopi WPA supplicant.txt, and a new file we're going to create, which is called ssh.nothing, SSH. So we're going to need to edit this file. It's a text file. Don't open it in Word. It will mess it up. If you open it in an editor like Notepad on a Mac that's designed to edit rich text files, it will mess it up. You have to open it in an editor that's in text mode. That means it's an editor designed for working with programs. I'm going to use Atom. Now you can use Notepad on the Mac in text mode. You can use Notepad on a Windows machine in text mode. I'm going to use something called Atom. So if I go back here to my browser, this is a wonderful editor that's available for every operating system. It's completely free. And so that's the editor I'm going to use. So let me right click on this and say Open with Atom. And inside here, you'll see a bunch of setup commands for your network. I'm going to show you the specific lines you have to change. Up here where it says WPA, WPA2 secured, if you have a standard home-based, office-based network, this is the section you want. You want to remove all of the pound signs. Pound signs say that line is a comment. Ignore it. From this section. It is very important that you remove the pound signs from all 4 of these lines. Then in the SSD quotes, you want to put the name of your network, your SSID, and next to PSK, you want to put your password. And then you want to save the file. That's going to allow your Raspberry Pi, when it boots, to read these parameters, because we've taken off the pound signs, and to automatically connect to the network. Then we can close it. Now, I'm going to go to my Atom editor, and I'm going to create a blank new file. And I'm going to say save as SSH, and where? I'm saving it on my boot device. That is going to allow you to connect in a terminal mode to your Raspberry Pi. If the SSH file is missing, it won't allow you to connect in terminal mode. So that step might not be necessary. Depending on your build, it seems the most recent build, it might not be necessary. Okay, now I'm going to eject that file. I'm going to take the SD card out of this computer. I'm going to put it in this computer. Now, the SD cards are interesting because they go in upside down. So I put that SD card in, and now we're going to connect this to power it on, and then connect to this device. So let me get those steps done here. So connect it to power. I'm going to attach my USB cable that I'm going to use for the printer. It doesn't matter whether I attach it to the blue USB 3 or the black USB 2 connectors. USB 3 is faster, but it doesn't really matter. Now, you'll notice on the end of my USB cable, I'm going to put this little device. What is this little device? It actually goes on this end. Well, the Raspberry Pi, when it's plugged in, and you're probably going to leave it plugged in most of the time, supplies power over the USB cable. That power on some printers will cause your LCD screen to be on all the time. Now, I'm not sure if that's a problem or not, but the folks at TH3D have produced this wonderful device. It sells for all of $7 that blocks that power so that there won't be power going to your LCD screen. Okay, I'm going to go over here to the side and connect this all together. Okay, I've plugged in my Raspberry Pi. I've plugged it into the Ender 3 version 2. I've even plugged it into a USB camera, a Logitech camera, and I'm using it on a little tripod, but you can use it on a variety of attachment stands that will attach it to your printer. And now I'm going to access the Raspberry Pi the first time. So I go to octopi.local. Any address that ends in a .local is a special reserved address for your local private network. And Octopi is the host name. So let's see if we can access this. And I'm using Chrome, but you could use any browser. This is not browser dependent. And we'll see we're going to load a setup wizard. Now, if this doesn't work, and it actually didn't work this first time I did it, I went off camera and fixed it. I typed in the wrong password for my Wi-Fi network. So you have to double check that network configuration. If you get that wrong, it won't work. So I'm going to go through this and click on next. Yes, I'm going to use access control. So we're going to give it a username, and I'm going to give it a password. And whoops, let's make sure they match. There we go. And then we will keep access control enabled. And that's my password saver that came up in the corner. We're going to keep access control enabled, click on next. I'm going to allow the author Gina to have some anonymous data about how I use this. So I'm going to click on enable and next. Now I'll scroll down to the bottom. I'll enable the connectivity check, click on next. I'll enable blacklist processing. That's sort of a spam, a virus protection feature. Click on next. Now, I'm going to use this box for a variety of printers. I have 8 different printers here around the Dr. Vax lab, and I only have 3 Raspberry Pis that I use for this, so I move them around. I'm going to make this my Ender style printer. I'm going to set the print bed as rectangular, and all of my printers are at least 220 by 220 by 220. I can always change that later. The axes, I'm going to leave these defaults in place, and the hot end, you want to make sure your nozzle diameter is set to 0.4, leave that in place. And now I'm going to click on finish. Now, if everything is connected properly, I should be able to click on connect here, and it failed. Well, it failed for a very good reason. I didn't turn on the printer. So let me roll over here and turn on the printer. Give that a second to boot. And click on connect. And now I'm connected to the printer. Okay, now that we have Octoprint up and running, let me take you through it very quickly because we could spend a whole half hour just talking about Octoprint. Maybe we'll do that in a future video. So across the top here, you'll see the displays for the current temperature of the printer. Control will show you your camera. Now let me move this camera over a little bit here so we can see. And you could position the camera anywhere you wanted. Control will show you what's in the camera. Once you've loaded a Gcode file, you'll see your Gcode here. And this terminal window is very interesting. What you're seeing now are reports of the temperature. If I type in here a Gcode command, M155S0, it will turn off that temperature reporting. And what this says is report temperature automatically, and the S0 says turn it off. Now, Octoprint is sending an M105. When it sees that automatic reporting is off, it sends an M105 to get the temperature. We're going to suppress those messages by clicking here. Now, in this window, I can talk to the printer directly as if I was a Gcode file. So let's do an M503. And what you'll see I'm going to get back here are the basic parameters of my printer. Okay, so we've learned about the temperature screen, the control screen, the Gcode viewer, and terminal. Time-lapse is Octoprint has the ability to take snapshots of your print over time. And those are done with the attached camera. And you can do those in a variety of different ways. You can do those every X amount of time, or every time the Z-axis changes. So when you go from layer 1 to layer 2 to layer 3. Now, how do we go about printing a file? Well, the first step we have to do is open up a slicer. I'm going to use Cura here. I'm going to take and let's say I want to slice this pop can opener, find a file I want to slice. I'm going to slice that file, which is the act of converting it to Gcode. I'm going to save that to a known location. And now I'm going to go back to Octoprint, click on Upload, navigate to the directory where I saved the file, find the file, open it up, and you'll see it'll go to the top of the list. If I click on the print icon here, it will be loaded into this section. It shows me it'll print in 19 minutes. And now I can go to the Gcode viewer and I can actually see that. I'm going to click on Sync with Job Progress. So that's going to only show me the Gcode as it prints a particular level. I can go to the temperature screen here and I can see the progress of the printing, both in percent over here, and I can actually see the temperature as it ramps up. I can go to Control. Once again, I can see the printer. If I went to Terminal, I'd see and scroll down to the bottom and click on Auto Scroll. I'd see the different commands that are being sent to the printer. And that's basically it for Octoprint. So you slice your file, you upload it to Octoprint. There is one other capability that'll make this even easier. If you're using Cura, you can click on your printer name, click on Manage Printer, and you can say Connect to Octoprint. It will ask you for the Octoprint instance. I've already connected, so I have the API key. You can get the API key from Octoprint from the Setup panel or with this request function. I'm going to connect to the printer, and now when I slice a file, I'll have an option here for Print with Octoprint. In addition, if you're connected to Octoprint, in Cura, you'll actually be able to see your printer and see the percentage of completion of the print. Now, let's go back here for a second. I'm actually going to cancel this print because I want to do one more thing. I want to show you one more thing. I want to show you how to secure this instance of Octoprint. To do that, we're going to use an SSH emulator. SSH stands for Secure Shell. It's a terminal protocol. I use Terminus because it's available on both Windows and Macs. We're going to open up Terminus. I'm going to go to my octoprint.local instance that I had already configured by clicking on New Host. I'll go over here and I'll show you what I've configured. It's set up as an address of Octopi local. Username Pi, password is Raspberry. Username Pi, password is Raspberry. I'm going to double click on that to connect. It's going to tell me that this is a different Raspberry Pi than the last one we connected to on Octopi local. I'm going to say that's okay. And now we're logged into Octoprint. And we're logged in on a terminal emulator. So now I want to configure this to be more secure. So I'm going to type in a command sudo that says run in secure mode, raspi/config. And the first thing it's doing is prompting me for my password. So I'm going to type in Raspberry. And now we'll see we're in a terminal window. So I'm only going to do a couple things here. The first thing I'm going to do is go to change password. I'm going to put in a new password. So now my password for Pi will no longer be Raspberry. It will be the password I've entered in. And the next thing I'm going to do is go to localization options and select change time zone. And I'm going to select the proper time zone, US. In my case, that would be Central. Click on Finish. And now I'm all set. So I've changed the password on my Raspberry Pi so it's more secure, and I've changed the time zone so it's the correct time zone. So if I type in the command at the command prompt of date, you'll see it's the 29th, that's the right date, and we have 10:53, which is the correct time. So now I can type exit to exit out of that program. That will be important because when I'm looking at completion times or looking at log files on Octopi, I want it to be correct. Well, folks, I hope this was helpful. I did find one interesting thing that you're going to want to know about, and it's a limitation of this new Ender 3 version 2. And that is there's a command used in a lot of software called the M117 Gcode command. And you type M117 and then a text string, and on many printers it comes up on the bottom line of the LCD. I tried that here. There is no bottom line on this LCD. Now, there's space on the screen they could have put it in. I'm not sure why they haven't. It gives you an OK back that it works, but right now, software that relies on M117 to put things on the display will not work. However, the M300 command, which beeps, does work. So just a little hint about this new Ender 3 version 2. Folks, I hope you liked this video. And give me a thumbs up if you did. Subscribe to the channel. Share it with everyone you know. Go to forum.drvax.com to discuss what you've learned here or ask questions from other viewers of this channel. And let's continue to learn things together.